Okay, let's solve three gas law problems. For each, we'll use the same strategy. Anytime we get a piece of data, we're going to write what it is, and from those letters that we write, the formula should spit out, and we'll go ahead and solve it. Here we go. Boyle's law. A 0.4-liter engine, that must be the volume of the cylinder. Put a V above that. That's our original volume. At 2 atmospheres, that's our original pressure. It's increased to 20. That's our second pressure. When the spark plug fires, what's the volume at that pressure? They must be solving for V2. P1 times V1 equals P2 times V2, but I noticed that the pressure went up tenfold, so I think that the volume will go down tenfold to 0.04 liters, and I'm done. Right? We could do it systematically, plug in those numbers. 2 atmospheres at 0.4 liters will be equivalent to 20 atmospheres of pressure at a much smaller volume when that cylinder compresses. X equals 0.04 liters. It's always a good idea not just to write the numbers down, but the units as well and cancel them to make sure everything's lined up. Another problem. We got a 2-liter balloon that sounds like a volume, and it's heated until the gases warm from 25 to 323. Be careful, always add 273 at least, or 273.15 to your degrees Celsius to get your Kelvin. You have to use Kelvin for all these. So it's 298 turns into 596. Wow, it doubled. What will be the final volume of the balloon? You heat up a balloon, it's going to expand. If the temperature doubled, the volume will double. The answer is going to be 4 liters. We can solve it systematically. T1 over V1 equals T2 over V2. Replace those letters with those numbers, but don't forget the units. 298 Kelvin divided by 2 liters equals 596 Kelvin divided by X. The best way to solve those is to cross multiply. And you should get that X equals what you predicted, which is 4 liters. Finally, let's do a gas law problem for a non-expandable system, like a bottle. This is a Gay-Lussac's law problem. We've got a closed, fixed volume aluminum can in this case, but it's only got air in it. It can handle a pressure of 4 atmospheres before it bursts. I don't think I'm going to write down that as a pressure. I'm just going to solve the problem and see if it exceeds that, and the answer will be yes. If this closed 2-liter can, boop, there's my volume, right? At a pressure, oh, and I should ignore it. Yes, 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 I forgot that. It can't expand, so it doesn't matter, right? At 1.2 atmospheres, that's our original pressure, goes from 25 to 100. That means 298 to 373 Kelvin, which is not even doubling. Therefore, the pressure will increase, but I don't even know if it's going to hit 2 atmospheres, so it certainly won't exceed the 4. In my head, the answer is no. The pressure is only going up by about 20%. I should say the temperature is only going up by about 20%. So will the volume. Let's do T1 over P1 equals T2 over P2 to verify. Plugging in and solving for X, we see that X equals 1.5 atmospheres. Be sure you answer the question, which is, will it burst? Answer, no. This is Boyle's law, Charles' law, and Gay-Lussac's law sample problems.